Before we get into a whole bunch of work with rational expressions, we're going to talk about something called non-permissible values. Whenever you use a rational expression, you must identify any values that must be included. Those values are called non-permissible values. What it means is you have this expression that's only defined for certain values of the variable. So if the variable equals a certain thing, then that expression is not defined. It doesn't exist. And the values, when we're talking about rational expressions, are the values that make the denominator equal to 0. Because if you have something like this, let's just say 3x over y, that's a rational expression, right? But what happens when y is equal to 0? It's dividing by 0, and you can't divide by 0, so it's undefined. So the non-permissible value for that would be y equals 0. That value is not allowed, because if you have it, the whole expression is undefined. It doesn't exist. So we're going to determine the non-permissible values. NPVs means non-permissible values. And we'll start with this one. So we're not going to try to simplify or anything. Actually, that one can't be simplified. But I just want to know what values would not be allowed. What values of the variables. And those will be the NPVs, or the non-permissible values. So what value could you fill in for one of the variables that would make the denominator equal to 0?
0.
0 for what?
S or R.
S or R. So here are the non-permissible values. S cannot equal 0, and R cannot equal 0. That's it for that one, yeah. Because if you put a 0 in for S, the whole denominator becomes 0. If you put a 0 in for R, the whole denominator becomes 0, and you're not allowed to have that.
Is it always 0?
It's not always 0, no. But for this one, it's 0. So here's another one. 3x over x times 2x minus 3. What are the non-permissible values? What are the values of x in this case, because this one just has x's, that will make the denominator equal to 0? 0. X cannot equal 0. Because then the whole denominator is 0, right? Because it's 0 multiplied by something. What else could x not equal?
1.
You need to take each factor in the denominator and make it equal to 0, or actually make it not equal to 0. So x does not equal 0, that's easy. But the other one, it's 2x minus 3 cannot equal 0. That factor cannot equal 0. If it does, then the whole thing becomes 0. So you can just solve that for x, or not solve it for x because it's not equal. So I'll add 3 to both sides and then divide by 2. So we get x cannot equal 3 over 2, which is 1.5. Here's one more. See, this is the third one, right?
I was enjoying the battlefield.
2p minus 1 over p squared minus p minus 12. What are the non-permissible values? So what can p not equal?
0.
So everybody wants to say 0, right? Because the other ones were 0? But 0 is okay here. If we fill 0 in, it's just a negative 12 on the bottom. That's fine. We need to take that denominator, just the denominator, p squared minus p minus 12, and say that cannot equal 0. What kind of equation is this? Or actually, it's an inequality, but it's standard form of a, what is it?
Quadratic.
Quadratic. Yeah, how do you solve a quadratic? Factoring, or the quadratic formula. So let's factor it. think this one's easy to factor. If I factor it, then I can come up with those, oops, I said equals 0. I should say not, does not equal 0. P minus 4 times P plus 3 does not equal 0, because that's just the denominator. So then what can P not equal?
4.
4. Somebody said 4, right?
Yes.
And P cannot equal -3. Those are the non-permissible values for this one.